Hello and welcome. I'm going to start where I left off in the last video by fixing my taper lock on the final drive here on the gearbox. I'm going to stick this all back together and I'm going to get some testing done hopefully. Everything's back together. Now it's time to test it at the higher RPM with the higher gearing. So to start off, I'm going to do the flow test. I figure this is a pretty good starting point. It's not the maximum I intend to push this supercharger, but it's a good place to start for fueling and whatnot. Now that my flow rates are at a pretty good place to start, it's time to see if I build any pressure at this flow rate. Suddenly I run into a big issue. It seems that the carburetor has flooded so much that it has filled the cylinder with enough gas that it hydrolocks. This should be a quick fix. Turn the fuel off and pull the spark plug and kind of run it a few times, just spin it around and push all the fuel out. Unfortunately, pulling the spark plug's not really a feasible option for me. There's a bunch of gravel and tar. I can't really get it all out, and I don't really want to risk any chunks of rocks getting inside the engine. Perfect, above ambient by about 1.5 pounds. I'm pretty excited to get this thing stuffing air into the engine, but I've got a few more things I got to do before that. Since I can't really use the original carburetor the way it is anyways, I might as well take it apart and do something about my head issue as well. Not that I figured there was anything wrong, but while we're in here, we're going to take a peek at the bore. Everything looks nice and shiny. You can even see some of the crosshatch marks still. This engine's actually not that old, apparently, or at least doesn't have that many hours on it. Since the head's off, I could just clean it and whatever. I don't have to worry about anything falling in the engine. However, I do have another head that I started doing a lot of work on for a naturally aspirated build a long time ago. It's been port and polished, and the deck has been planed down about 15 to 20 thou. I forget now exactly how much I took off. And I took out a bunch of material out of the combustion chamber to try and smooth out the flow patterns. Before we get into putting the new head on, I got to clean the old gasket off of here first. Just going to carefully peel up the edge from the squish ring and kind of pry it from there, being that's the sturdiest point. I don't really want it to fall apart and have to scrape it real hard all the way around. After that, I just scrape off some of the leftover residue and we're good to go. Before I can put the new head on, I have to finish building it, and before I can put the valves in, I need to finish lapping them. I had started this process before but never finished it and just kind of shelved the whole thing. How I'm going to do this is with valve lapping compound or valve grinding compound, depending on who you're talking to. I'm going to place a bunch of the compound on the back of the valves where it seats. I'm going to install the valve and we're going to rotate it. Now, I cheat a little bit and use a drill sometimes, but in this application it's a little bit hard to get at. With the valves lapped, I'm ready to install the springs. However, I got to install the intake valve seal first. Then I got to put in this little buffer here at the bottom of the exhaust valve spring. I think it's some sort of insulator. And then I can just toss the springs in. Now these are not like cars, they're not that difficult to put in. You just kind of push them down and slide them over and they lock in. I was going to do a leak down test, but my air gun grew legs and wandered off, so I can't put pressure behind the valve, but I'm going to let it sit here for about 10 minutes and see what happens. After 10 minutes, everything's dry underneath, so I'm going to dump it and clean it up and start putting it together. Alright, it's clean, compression's up, and it should flow a little better. Now, I need to look into fueling. I have a few options for this, one of them being use the original carburetor and 3D print a box to put it in. This box will be sealed on everything but the inlet and the outlet, and that way the carburetor won't know any difference and the entire atmosphere around the carburetor will be higher pressure. This option has its advantages and disadvantages. One of the advantages is it's fairly cheap and simple, although I was going to use a servo for the throttle to make it easier to seal, so that adds a little bit of complexity. One of the disadvantages is it's kind of a pain to work on, so if I have to adjust this or do anything to it, I have to pull this whole box apart and then make sure it's sealed when I put it back together. The other option readily available to me would be to use a Mikuni carburetor and make some minor modifications for it to handle boost. Now for the most part these are relatively sealed anyways, because usually they're used in applications where they might be wet, like on a four-wheeler or a snow machine. There shouldn't be too much involved in modifying this carburetor to handle boost. I'm likely going to go with a plenum and have all of the vent lines and everything run into the plenum so they see the higher atmospheric pressure, so everything is balanced inside and outside of the carburetor. I'm also going to need some sort of fuel pump that runs ultimately 1 to 2 pounds higher than any boost pressure that I have so that it can fuel it. That, or I have a really big tank really high up. This isn't really the best idea for, a motorcycle or some sort of other device that I can ride on, but it might work for this test application. I was also thinking about seeing if I can double up 2 diaphragm pumps in series so I can increase the pressure, but I think they only run 2 to 3 pounds each anyways. I might end up going with an electric pump. I'm going to have to do some research before that as well. At any rate, this is about as far as I'm going to get this week if I want to get this video out for this week. If you like this and want to see what else is coming next, subscribe and click the little like button. Otherwise, have yourselves a good one, guys. Take it easy.